Hi everyone, I'm really excited to interview Angelos Chronis. He's head of City Intelligence Lab at AIT. He teaches at IAC and program chair of SimAUD Symposium, which is based on simulation for architecture and urban design. I'm accompanied by Deepak Siva, and you might have seen our interview recently. In this interview, you will get to know about Angelo's journey, thoughts on performance driven design and simulation, development of infrared AI based framework for urban planning, along with advice to young professionals to get started who wish to do similar work. So, without much ado, let's jump into the interview. So, Angelo, can you tell us briefly about your background?
Yeah, sure. Oh, thanks first of all for having me, and then hello to everyone who's watching. So I'm an architect. I studied architecture in Greece, where I'm from. I'm from Greece, at the University of Patras, and I wasn't really a great student of architecture, so it took me a little bit longer to finish. I couldn't really relate to the way architecture was taught and practiced there, and so at some point I jumped ship and started becoming let's say a computational designer. Back then it wasn't really very much a term. Like it was more like some people doing some really weird coding stuff. So I went to London, studied at the Bartlett at the Adaptive Architecture and Computation course, a great course with great tutors. And then from that, I followed sort of like a kind of like design research and development sort of career path in a design firm. So I went to work at Foster's for 5 years, and then at the same time I was teaching at the Bartlett, and then finally I just decided I didn't like the practice also that much, and I went to academia. So that's where I landed at IAC, the Institute of Advanced Architecture of Catalonia in Barcelona, where I also met Deepak, one of our really bright students,
Thank
which
you.
I'm really happy to see here. And yeah,
Great
it's
to see you
really
too.
great to see you progress so well. And yeah, from that I did a PhD there at I was a Marie Curie fellow, and then moved and I ended up in Austria after that in the City Intelligence Lab, which I'm heading at the Austrian Institute of Technology, which is actually sitting in between, let's say, architectural practice and research. And that's why I like it, because I can be in between both worlds. And the thing I can say is, I mean, if I can offer only one advice to everyone who's maybe studying now or whatever, is, if you're disappointed with something, just don't need to follow it up. You just can find another way. I mainly went into computational design out of the disappointment from architecture, and I ended up doing really well there because I really loved what I was doing. So you don't really need to stay somewhere you don't like. That's my only advice. So just explore. I wouldn't necessarily advise someone to become a computational designer today. There's enough computational designers in the world. It's a great field. I love it. But yeah, you could be doing something completely different. You could go into, I don't know, participatory design, or you could go into, maybe machine learning or AI, which is of course, taking up a lot of our current research. And this is what I'm actually doing right now, mostly focusing on AI and machine learning. That's what we're teaching also in IAC and in Bauhaus and other places.
It's interesting to see like how you tried different things and ultimately you found your interest and pursued in that path. I'm curious to know like if there is any particular incident or highlight from your academic career or professional work which really shaped your like design philosophy.
I love this question. Very nice. So I think that people make the difference. So for me, I was really lucky when I was in architecture school. I met a professor, Catherine Liapi. She's an incredible human being and an incredible professor as well. And she really guided me through this, world of computational design. To give you an idea, when I started, this was around 2005, 2006 or so. There was no, Grasshopper. There was no sort of there were a bunch of people doing some really crazy work with generative components, and Grasshopper was just about to start. It started in 2007. So I was she opened up a world that I've never seen before. And I started studying a lot of research papers and understanding, digital fabrication back then, because that was also sort of my interest. And I think if you follow, if you really follow your passion, if you find people that open up, new worlds for you, you can, you need to push through. You need to take these opportunities and go for it. You don't be afraid to experiment. That's why, because yeah, back then I had nothing to lose. I was not really a great student, so I was yeah, this is a world I've never seen. I really loved it. I looked very similar to what I liked. So yeah, I followed it. need to invest a little bit of time in the beginning. I went to some sort of like workshops. I went to San Francisco and followed like a conference there. Like you need to invest a little bit of time. And there's one thing perhaps I can say, which I say very often to students, like if you don't have a computational designer job, right? If you're not really right now working for someone that does research, right? And you really want to do that, you don't have to wait. You don't have to be hired to do this. You can just do it yourself. You can just start a project. You can start a research project by yourself in a company that you're already in a conventional sort of like office. You don't have to really wait for the paid, job to do this. You can push through yourself.
Connecting back to you mentioned about AI and machine learning, we would like to know, was there any defining moment when you realized machine learning can be a game changer in AEC?
It's interesting. So, I mean, the first time I came across like neural networks was when I studied at Bartlett in 2009, and I kind of like didn't really get much into them. I liked them a little bit, but like never really got into them a lot. I was like mostly kind of like involved with genetic algorithms, for example, not really looking into neural networks. And I was teaching neural networks for like about 5-10 years at the Bartlett. So the first 5 years, like, didn't really care that much about them, but like the hype was constantly building, and you could see that they would influence the world. Like, so yeah, although I didn't really invest much time on them before, like when I sort of like when I was in the academic world again in IAC, and I realized that there's a lot of potential, I decided to get more into it. I have to admit that my position at the lab is more like kind of like, because I'm heading the lab, I'm more like steering the development. I'm not really the person who will write all the code that you see. So I was really also lucky to get really bright people to work with me. So Theodore Galanos, Narid Kin, and Seriosa during our like 2 PhDs, and one of our senior researchers, Theodore. They're like really, really bright people, and with them, it's really much more easy and possible to do all of that. So I think it's like, again, I think it's people that make a difference. It's not like it's not like concepts only. It's the people who you connect to.
I see, that's a really good piece of advice. And can you just give us like a overview about your professional or research work, like few key projects?
Yeah. So one of the things that we've developed in the lab very recently, and that's one of the things that we are mostly well known about, is infrared. It's called Intelligent Framework for Resilient Design. Has a catchy name, so it's easier to remember. So infrared was something we started developing with Theodore and like Yosha and Naid and like some collaborators from the UK. Now we've like pushed a lot to do this, and it's essentially using kind of like cutting edge machine learning models, like deep learning models, we can call them, like GANs or CNNs or other like reinforcement learning or other concepts. It doesn't really matter, and it's kind of like allowing people to, let's say, answer very quickly questions about design in a very, very responsive manner. So for example, we have one of the things we pioneered on is doing fast sort of like CFD predictions. So wind simulation. So the wind simulation takes normally 5 hours, and you do that in a few seconds with infrared. And that's really a breakthrough, something we were like mostly known of. And we are actually releasing, it's a good moment to say that we're releasing in infrared as an online platform in a couple of weeks. So I'll make sure that I'll send you the link when it's ready, so that you can maybe disseminate it with your viewers, so they can actually have a look. And we're really proud of this sort of like framework, because it really gives people the ability to understand a little bit better their design decisions and their impact. It was not as easy before. Like, of course, there's all these tools, like you open Food for Rhinos, like tons of there's like today there's like 3 CFD sort of like interfaces, which was nothing like that was existing. Like when I did my PhD, it was like 4 years ago. We didn't have that already. I mean, we had Butterfly, and that was it. But yeah, so I think that's one of the main things. Of course, we are also doing other things in parallel. Like we currently work a lot with mobility and sort of like transportation accessibility concepts, because we also like recently merged two units in AIT, and we are part of that. Yeah, it's a lot of excitement there, and you'll see more of that in the future. But yeah, I mean, I think the main sort of like development we had was infrared.
I see. Now I will hand over to Deepak for next set of questions.
Yeah,
Sure
so
thing.
I was just thinking of asking all these questions, like where did you write your first piece of code, and what did you take it in that direction? Like I see most of the professors are more into algorithm of like grasshopper and designing. You're like more into teaching processing and So what
Yeah.
made you like choose that direction, which is like usually different from what my other professors were following? Like they were into digital fabrication or computational design in terms of grasshopper parametrics and stuff like that, but you're more into pixels and processing and machine learning and all this. Like what
Mhm.
made you choose that direction? Like, and where did you write your first piece of code?
When did I write my first piece of code? Is actually very interesting. So in Greece, when you're studying architecture, you have like a 5-year diploma. So in the first 4 years, you're like doing mostly like courses and you're learning about things. And then in the last couple of years, in the last year, sorry, you're doing like there's like a research thesis and then a practice thesis. Sort of like like first it's like you're researching a subject and then you're like proposing some sort of like design for some sort of like building. It took me like instead of like a year, it took me like a year, 2 years and a half or 3 years to do these two concepts, and that was a very good choice because I learned a lot. So the first thing I did like is study. Like really, I was studying for a year and a half. I was reading papers. I read hundreds and hundreds of papers about performance-driven design and digital fabrication, all of that. So, and I wrote my research thesis, which was like probably the most educating thing for me because I knew already what I wanted to do. I knew I wanted to do performance driven design back then, and I'm still doing the same because I kept reading about we're talking about 2007, right? 2006, seven or so. That's when I did my research. These people were talking back then a lot about digital fabrication. Gary and like CNCs and all of that. There was no robotic fabrication back then, but it was coming. And all of this like digital fabrication, custom, like mass customization was the big buzzword back then. And people were talking about like how they can make the buildings form in whatever like complex geometry they want, and like building components, very 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 kind of like elaborate complex geometrical components. But they were like always like talking about like how beautiful they can be or what the form of them can be. Like no one was interested really in how they perform. So my from the beginning, my sort of like direction was I just want to do performative buildings. I want to use all of these sort of like capabilities that essentially we've just appropriated these capabilities from aerospace or nautical engineering, right? It's not something new. Like we're not doing anything in architecture. We're just taking these things. Of course, the new thing is that we're making buildings out of them. But I think we've spent too much time trying to make like 3D studio sort of like beautiful forms into buildings, or like CATIA, using CATIA to just like fold metals and make like a beautiful facade. So I was interested always in the performance driven design. The first piece of code I wrote was for my practical thesis afterwards. So I went to San Francisco. I went to Smart Geometry 2009, and I learned coding there. And then I did my first code, which was terrible, absolutely terrible. It was in generative components. It was just a script, and I had just learned like how to do a couple of for loops, and I did like a few for loops to just design the building. But what it did use was I had like done very elaborate environmental simulations. So I was doing CFD back then. So I had done CFD and solar sort of analysis, and I was using all of the environmental parameters of the site to drive the form. So the form was driven by environmental parameters. It was really well received. We published this at the ICAD conference, and then it's probably one of the most interesting publications I've had up to now. It's called Parametric Approach to Bioclimatic for the Bioclimatic Design of a Student Housing Project, and that's probably my best publication up to now. Yeah.
Okay, that's nice to hear. Okay, but the next question for me will be like ICCT Intelligence Lab using GAN for accelerating optimization processes. What about other approaches of machine learning, especially reinforcement learning? How are you like planning to implement that into the process?
So we're not using GANs as generative models at all. We're just using GANs to predict the performance of simulation performance. So we're not really using them for what they are like good, which is a generative aspect. But yeah, we do things like, for example, we did a few experiments with reinforcement learning on how to, let's say, like optimize a building, like a building's form or a building's like orientation using reinforcement learning. So like using the environment as a sort of like the driving force, and then the building as an agent, and then moving it around inside the site, and then like finding it reorganizing itself and finding the right position. What we're also doing some other sort of like experiments right now, which are not necessarily, not necessarily like in machine learning models, but like they're like more like in the data science sort of like realm, for exploring design spaces without really like using the cumbersome parametric models that like we are used to. Because like, when you build a better parametric model for a sort of like a design problem, you always have to reinvent at some point, like, every time you need to reinvent a whole design process, which is not really ideal. So we'd like to go directly from, you designing a few buildings to a machine proposing to you a few alternatives without you like really creating parametric model. This is a little bit early to talk about, but we can, this is one of our like next steps. I also think that it's important to like design to develop for designers, like, because we sometimes we just like to develop for developers, like, we just want to like create very complex codes and very complex systems that only people who are experts can use. We don't want to do that. Like, we really want to focus on people who like, who people want to design, people who just want to create interesting, like, buildings and interesting conditions, urban conditions. So that's our goal.
Mayur will ask you the next question.
Yeah, so what are some books, conference or courses you would recommend to people who are just starting out?
Oof, that's one of my most sort of like favorite writers is Branko Kolarevic. He has written 3 books that I think are very useful. One about digital fabrication, the other about performative architecture, and the other about material effects. These are really old though, but his work is still very relevant. Ali Malkawi has really great publications on performance-driven design. I think he's one of the really great sort of like writers. Then I'd say, I mean, in terms of like conferences, if you're interested in simulation and machine learning and all that, like SimAUD is by far for me the best conference. Simulation, architecture, and urban design. It's really a great community. If you've never been there, go. It's this year. It's in California, but it's online. So you really like, you will not lose by being involved in that community. It's really a great community. Of course, E02 or Cadria if you are in Asia, or Acadia, but you probably know all of these are all like very, very, very kind of like great communities. I started everything that I've done. I've started from CuminCAD. CuminCAD is the cumulative index of CAD. CuminCAD is the platform now developed my good friend and colleague Gabriel Wurzer, the platform that holds all the conferences except for SimAUD. SimAUD has a different sort of like, you can find everything online, but it has all the kind of like papers of the conferences. I spent really a year in CuminCAD before I do anything else. There's a lot of information there, and if you start to untangle like this, or like the web of information of all the people, the authors there, you will find like a lot of great people there. And my papers are also there, so if anybody wants to like find them, they're all there. It's open and it's very easy to access. I would start there.
Any concluding statement you want to share?
My only kind of like advice is like really experiment. Like don't listen to any professor, any teacher, or any sort of like authority, and just find your own way. Everybody started like from knowing nothing. You can you will definitely be more knowledgeable from all of the people who advise you right now. So yeah, just push through with your interests, and don't forget that it is all fun at the end. Like, we're all doing this because we want to have fun, right?
I see.
That's my comment. Thanks.
Thanks a lot, Angelos. It was a very fun interview. Thanks for sharing your
Thanks.
thoughts.
Thank you.